Okay, grade 8, this is your Introduction to Pythagorean Theorem. Section 3.1 is on squares and square roots. Now, we've already done the show you know in class, but I'm going to go over it one more time just to kind of have a reference for you guys who maybe didn't understand it the first time to kind of be able to follow. The first show you know says write the prime factorization of each number, and which number is not a perfect square, and explain how you know. So the reason why we use prime factorization is, by definition, a perfect square is a number that can be written by multiplying a number by itself, okay, or having an identical pair of factors. In the case of 36, for example, you can write that as being 6 times 6. Those are both factors that are the same. When we prime factorize, what we try and do is we try and make uh, prime numbers, the product of prime numbers, to make those numbers. So, for example, any number, for example, we'll make the number 8. 8 can be written as either 2 times 4. This is a prime number, and 4 is not. And 4 can be written as 2 times 2. So the number 8 can really be expressed by multiplying the prime factors of 2, 2, and 2 together to get 8. Okay? Now, if a number is a perfect square, the prime factors that you have will be able to create two identical numbers using those prime factors. In the case of 8, I can't make two identical factors. I can make a 2 times 2 on this side and a 2 over here, but 4 times 2 is the best way I can express how to get 8. In the case of the examples of the actual unit, we have the number 45. And what we want to do is we want to break 45 down into the product of just prime numbers. Now, your prime numbers, your first 10 are 2, 3, 5, 7, 11, 13, 17, 19, and 23. Those are your first 10 prime numbers. Now, a prime number simply means it only has one in itself as factors. So any number that you can think of can be made by multiplying a string of these numbers together. Well, not just those, but numbers bigger, but any number that we think of that's a regular number, excuse me, can be made by multiplying those together. So the number 45 can be created by multiplying a combination of these prime numbers together. What we do is we break it down one number at a time. So 45 can be created by 9 times 5. This is a prime number because we have it right here. And 9 is not prime, so that means we can further break it down into the product of different prime numbers. 9 can be broken down into 3, which is prime, multiplied by 3, which is prime. So really, the number 45 can be achieved by multiplying 5 times 3 times 3. Using those three prime numbers, if I multiply them together, I get the number 45. Now, because a perfect square has two identical um, factors, I can't take these three numbers, 5, 3, and 3, and put them into equal groups. I can only do that, which means the best way I could show it is either 15 times 3, or if I rearranged it like this, I could have 5 times 9. That's another way to get 45, but I can't multiply a number by itself based on the prime factor, so therefore it is not a perfect square. If I look at the number 100, I can break it down a whole bunch of different ways. I can break it down into 10 times 10. I can break it down to 2 times 50. I can break it down to 4 times 25. It really doesn't matter what you start with. I'm going to start with 4 and 25. It doesn't matter. Neither one of these numbers is prime, which means each of them can be broken down further into prime numbers. This can be achieved by multiplying 2 by 2. So instead of saying 4 by 25, I could say 2 times 2 times 25, and that also is a way to get 100. And 25 can be broken down into the prime factor of 5 multiplied by 5. So really I have another way of saying 100. I could say 2 times 2 times 5 times 5. Or if I wanted, I could rearrange them into 5 times 2 times 5 times 2, which means I could rethink this as being 10 times 10. And since I can re-envision the number 100 as being a number multiplied by itself, it means that this is a perfect square. And it also means that the square root of 100 is 10. The second show you know says determine the area of a square with a side length of 16 millimeters. So here's our square. We're going to put these little lines here to signify that each of those side lengths is equal length. We're going to put a right angle in there to show that this is 90 degrees and not a parallelogram, but a square. And we're going to put 16 millimeters here for our side length. Now, the formula for the area of a square is side squared equals area, or area equals side squared. We don't say length times width anymore because we understand what exponents are. So if the side length is 16, I could substitute that into my formula. Let's say the area would therefore be 16 squared. And 16 squared, if we simplify it, means 16 multiplied by itself. So 256 equals the area. So the area equals 256 square millimeters. Now, if I wanted to, I could show you that a different way. I can go insert, and I can put a table. The table can be 16 by 60. Is it 16 by 16? Is that what it is? 16, that's 15. 16 by 16. Press OK, and it creates this lovely little grid here. This is 16 units this way, and this is 16 units this way. So if we think of this as being 1 millimeter, 1 square millimeter, a millimeter by a millimeter, this would be 16 by 16. There would be 256 square millimeters as the area of this particular square. That's another way to think about what that would look like. In the next question it says, what is the side length of a square with an area of 196? So again, I'm going to draw my square. I'm going to put my side lengths here, put my right triangle, right angle here, and I'm going to say the area equals 196 centimeters squared. I'm going to start with my formula. Area equals side squared. This time, of the two variables, A for area and S for side, this time I know the variable A, which is 196. And I'm going to say, okay, if 196 equals side squared, then I have to isolate for the side, which means the square root of side squared, meaning if I said, what's the square root of 5 squared, you would say it's 5, because 5 squared is 25, so the square root of that would be 5. So what's the square root of side squared? It's simply going to be side, or S. And if I do that to one side of the equation, I have to do the same thing to the other. The square root of 196 is 14. And therefore, 14 equals side. I can put that over here, 14 centimeters, and I've solved my question. Okay? Now, your first question says a rectangle has an area of 64 meters squared. Determine, using prime factorization, determine the prime factorization of 64. So I'm going to write 64 here, and I can do it any different way. I can do 2 times 32. This is a prime factor. This is not, so it can be broken down into 2 times 16, 2 times 8, 2 times 4, and finally 2 times 2. So another way for me to re-envision 64 is to say it's 2 times 2 times 2 times 2 times 2 times 2. Is 64 a perfect square? The answer is yes, it is. And the reason why is I could take those 6 2's, put 3 of them on this side, put 3 of them on this side, and I would say I was able to distribute them evenly, and therefore I would have 2 times 2 is 4 times 2 is 8, 2 times 2 times 2 is 8, so therefore the square root of 64 is 8. It says draw a square with the area of that and label its side length. So here's our square. The area is 64 meters square, and the side length would be 8 meters. Question 8 says determine using prime factorization, or the prime factorization of each numbers, and which numbers are perfect squares. So here I'm going to go, let's just do 12 times 12, 2 times 6, 2 times 3. Same thing happens over here, 2 and 6. This becomes 2 and 3. So I can take all of those circled prime factors, 2 times 2 times 3, 2 times 2 times 3 times 2 times 2 times 3, and I will determine that that's 4 times 3 is 12. Since 12 times 12 is 144, I could say the square root of 144 is 12, and it is a perfect square because it has a number multiplied by itself that represents 144. 60 can be, well, we can go 6 times 5. That's one way. This is a prime factor. This is not. This is 2 and 3. So the only way I can create 60 using the product of prime factors is by multiplying 2, 3, and 5 together. I can't evenly redistribute those to make 2 even numbers, or 2 identical numbers, excuse me, which means 60 is not a perfect square. Oops. I got to do it again. 6 times 10, neither of which of prime. This is 2 and 3. This is 2 and 5. And even using 2, 3, 2, and 5, I can't rearrange those numbers to make two identical numbers. So I could say that 60 is not a perfect square. And with 40, I can go 4 and 10. Neither one of those are prime. This can be broken down into 2 and 2. This can be broken down into 2 and 5. I have 3 2s and a 5. I can't evenly create two factors, so therefore 60 or 40 is not a perfect square as well. Question 9 says, what is the area of a square with each side length? So for this one, I'm going to simply draw the square and label the side length. Since area equals side squared, I'm going to say area equals 10 squared, which means area equals 100. For here, 16, so area equals side squared, area equals 16 squared, area equals 256 units squared. For question 19, what is the square of each number? And some people get confused between square and square root. They are not the same thing. The square of a number simply means you take the number and you square it. So what's the square of 9? The answer is 81. What's the square of 11? It's 121. Question 13, what is the side length of each of the square shown? Since its area is 49, I can write my formula. Area equals side squared. 49 equals side squared. I don't want to know what side squared is. I want to know what side is. So the square root of both sides will isolate for s. The square root of 49 is 7, and therefore the side length is 7 millimeters. Question 14, to determine the side length of a square with an area of 900 centimeters squared. So same thing happens here. I don't know my side length, but area equals side squared. 900 equals side squared. The square root of each side. The square root of s squared is s, and if I take my calculator to find that it's 30, I can take my calculator and go, what is the square root of 900? And the answer is 30. So therefore, the side length is 30 centimeters. And question 19 says, a gym teacher told the students to run twice around the perimeter of a school field. The area of the square field is 28,900 meters squared. So here is the square field. The area is 2,890 meters squared. So they have to run twice around it. So the first thing we need to do is figure out how long is this length. So the area of a square equals side squared. I know the area. It's 28,900 equals side squared. So to isolate, I'm going to square root both sides. Square root of s squared is s. I need a calculator for this one. The square root of 28,900 is, oh, for heaven's sake, what is it? 28,900 square root is 170. So remember, we're not done yet, because all we know is that the length of the field, I'm going to write it on all of them, is 170 meters. So one lap of that field is really 170 times 4, which is 340, 680 meters. So one lap would be 680 meters. 2 laps would be another 680, which is 1,360 meters. That's the answer to the question. How far did each student run? 1,360 meters.